So now, how can you be able to calculate the center of a mass if we have the system in 2 dimension? Now, if we have the system in 2 dimension, the center of the mass will be given as a center of mass is equal to x subscript cm and comma y actually y should be comma y subscript cm. So this is how the center of the mass in 2 dimension may be calculated. In other words, we are going to have the center of mass along x-axis and also the center of mass along y-axis. And I will have the center of mass in terms of the coordinate system. Now, how should we have the x actually cm? So now the xm will be given as mass 1 times the x1, and let's say we can have mass 2 times x2. And if we have the system of the, let's say, 2 objects, it means we'll have that and as that. And let's say if we have the system of more than 2 objects, then it means the masses and their positions will keep on going in that way. So that's how the center of the mass of the system in a 2 dimension can be actually expressed. Let's say we have the system of the objects in 2 dimension. Let's say this is the case. And that should be that we have it in this case. Of course, this is y-axis, and this is the x-axis. And let's say this is actually 1, this is 2, let's say this is 3. And let's say this is 1, this is 2, and let's say this is 3. We have -1, -2, and there should be that. Let's say this is -3. And let's say this is a -1, and you have -2, and we have -3, and say should be up to -4 in that way. And now, assuming that we have, let's say, the object at this point, and let's say we have another object here, like that, and we also have the another object here in this way, and we should also have the something here in this way, and up to the extent that we should also have this in this case. And by the way, this is the reference point. This is the reference point, let's say, in that case. And assuming that this is object of mass 1, and let's say this is the object of mass 2, this is the object of mass 3, and this is the object of mass 4, and this is the object of mass 5. So now, let's say the coordinates at the point of the object M1 are given as x1 and y1. And let's say at the point M2, we have the coordinates given as, let's say, x2, comma, now I should have it this way. Now the coordinates at the actually mass 2, we have it as x should be 2, comma, y2 in that way. And the coordinates at, let's say, a point of mass 3, or have them as x3, comma, y3 in that case. And also in the same case, here we'll have x4 and y4. And here we have x5 and y5 in that way. So now, how should we have the center of mass and for this system? Now, since we have the system of, there should be 5 active masses, the center, and also being that the system is in 2 dimension, it means the center of mass will be given as xm, xcm, and comma ycm, where I will have to calculate the center of mass along x and that of along y-axis. The side has to be given in that case. Now, how should we have xcm? Now, the xcm, which is the center of mass along actually x-axis will be given as mass 1 and the times the x coordinate, that is times the position along x-axis, and for the actually object of mass 1 and plus now have m2 times the x coordinate at the point, that is given as x2 and the plus mass 3 and also times x3 and the plus mass 4 times, let's say, x4 as well. It's just unfortunate that the space is just too small, but let's have this. Now let's say this is the case. So we'll have xcm, that will be given as mass 1 times x1 in the plus mass 2 times x2 in the plus mass 3 times x3 in the plus mass 4 times x4 and also plus in that of and let's have here should be mass 5 times, let's say, x5 at that point. Then we'll divide by the total mass. And what is the total mass? And of which we have it as mass 1 times mass 2 should be mass 1 plus mass 2 plus mass 3 plus mass 4 and the plus mass 5. So now what is the actually x1? x1, it is the x coordinate at the point actually of mass 1 from the origin, and of which it will be given as L. And how about actually x2? x2 is the x coordinate at the point of mass 2 from the origin, of which it is this distance reaching up to this far. That will be given as 3. And how about x3? x3, it is the actually a distance, it is the x coordinate at the point of mass 3 from the origin, which is given as 2. And how about x4? x4, it is the distance from the origin along x-axis up to where the object of mass 4 is, of which it is given as L. And how about x5? x5, it is the distance from the origin to where the object of mass 5 is. In that case, will be given as the -3. So, mind you, actually x itself possesses the position. So it is showing the position can be negative or positive. So since the position it is actually along x-axis towards the negative actually values, it means the x5 will be given as the actually will be given as -3. So keep that in mind. And how about if we have, how about we should have the center of mass along y-axis? So which means we'll have it as should be y cm. That will be given as mass 1 y1 plus mass 2 y2 plus mass 3 y3 plus mass 4 y4 plus mass 5 and y5, and divide by the total of the mass, which is mass 1 plus mass 2 plus mass 3 plus mass 4, and up to mass 5 in that way. So which means we'll have the total of the masses in that case. So what is the y1? y1 is given as 3. And how about the y2? y2 is given as L. And y3 is also given as L. and y4 will be given as -3, and y5 is given as L. So keep that in mind. Now how about if we have, let's say, this system? Let's say we have the system of the center of mass in 2 dimension as well. Let's say this is the case. Let's say have it in that way, and also like that. And let's say have -1, -2, let's say -3. Now, assuming that we have the object here, let's say object 1, and let's say we have another object here, let's say object of mass 2, and let's say we have another object here, let's say it is the object of mass 3, and let's say we have another object here, let's say it is the object of mass 4. Now what is the center of mass for this system of the objects? So now, Stromo, this is 2-dimension case. Principle remains the same. We'll have the center of mass along x. That will be given as Stromo m1 x1 plus m2 x2 plus m3 x3 and plus m4 x4, and that divided by the total mass. Now what is the x1? So x1, it is the x coordinate at that point. That is given as, now should be 2. And how about the value of the x2? We'll have it as 3. And how about the x3? We'll have it as -2. And x4 is given as L, because at this point the x value is given as L. And also have the actually YCM, that will be given as m1 times, and that should be YCM, that is given as m1 times y1 plus m2 plus, let's say, m2 y2 and the plus m3 y3 and plus m4 y4, in that way, and divide by the total masses. So what is the actually y1? Y1, it is the actually y coordinate at the first point at the object of mass 1, that is given as 2. And how about the y2? We'll have it as 0. And how about y3? We'll have it as 0. And y4 will have it as -1. So keep that in mind. And sometimes we can also apply the concept of the vector resolution in some cases of, it depends on the way the system has been arranged. Let's say we have this case, and think about this. Let's say we have the system of the objects in a 2-dimension. Let's say this is the object of, let's say, mass 1, and assuming that this is the object, let's say, of mass 2, and we have another object, let's say here, of mass 3, and we have another object here, let's say, of mass, and that should be 4. And assuming that object of mass 1, it is at an angle theta with respect to the y-axis, and let's say object of mass actually 2, it is at an angle theta, let's say theta 2, below the positive x-axis. And let's say the object of mass actually 4, let's say it is at an angle theta, let's say theta 3, with respect to the vertical axis. And let's say the object of mass 3, it is at, let's say, position given as -2. Let's say this is the case, and the distance from the origin And at this point, let's say it is given us, let's say 5 meters, and let's say this is given us the 7 meters, this is given us, let's say 2 meters, in that way. What is the center of mass of this system? So now at the end of the day, we need to have x1, y1. That one will be obtained upon resolving this into components, of which I understand you know how to resolve the vectors into components. You resolve this actually a distance into components, where you have x component as well as the y component, and those components will correspond to this. So keep that in mind. Also in the same case, you also have that and as well, of which this one has a 0 component along y-axis. So make sure that you can remember about the vector resolution, of which you have to resolve that this is y and this is x. Also this is y, this is, you can have this x, and this is y and this is actual x. So try to go through such actual cases. You'll be able to have to master those. Now let's say we have this typical system, and where we have, let's say this is the object of mass, should be 5 grams. Let's say this is M1, and it is at an angle of, let's say, 25 degrees in this case, 4 meters. And let's say we have another object here, let's say of mass 2, it is given us, let's say, 51 kgs, and the distance, let's say it is given us 5 meters. And let's say we have another object here, let's say of mass 3, it's about, let's say, 20 kgs, and assuming that the distance is given us, and that should be 49 degrees. And let's say we have another object here, let's say of mass 4, which is given us, let's say, 40 kgs, and the distance is given us, let's say, 8 meters. It is at an angle of, and that should be 61 degrees with respect to the y-axis. What is the center of mass and for that system? So try to see how best you can go over that. And how about if we have, let's say, this system? Let's say we have this system, and of which, let's say, this is 1, let's say this is 1, this is 2, this is 3, let's say this is 1, 2, let's say 3, of which we have it as x-axis and y-axis. Let's say this is -1, -2, -1, let's say -2, -3. Let's say this is the object of mass, let's say mass 1, given us, let's say, mass 1 is equal to 50 kgs, and we have, let's say, object of mass 3, and that should be mass 2. Let's say mass 2 given us 60 kgs, and let's say we have here the object of mass 4, which is 40 kgs, and we have the object of, let's say, should be, this is mass 3, and let's say this is a mass 4, given as, let's say, 20 kgs. What is the center of mass in for the system? So try to see how best you can go and for that. Now, so that's how the center of mass in a 2-dimension actually can be calculated. Just have to be well conversant with the concept of the vector resolution, then you have everything in the right way. Thank you.